Good afternoon and welcome to this Bright Talk panel discussion here at Big Data London. My name is Richard Corduroy from Oakland Data Analytics and I'll be the moderator this afternoon. This is a live webinar and we would really encourage feedback from the floor, so if you have any questions please type them in and we'll answer as many as we can through the presentation. I'm delighted this afternoon to be joined by three esteemed members of this community. Matt Harris, Head of IT from Mercedes-AMG Petronas Motorsport, Alex McMullen, CTO of Pure Storage, and Michael O'Connell, Chief Analytics Officer at TIBCO. So before we get going, can we just give 30 seconds of yourselves, guys, and to introduce yourselves to our viewers.
I'll go first. So Matt Harris, Head of IT from Mercedes-AMG Petronas Motorsport. Been with the team 20 years this year, seen it in various guises, overall responsibility for IT within the team, and obviously key partners next to myself that I'll let introduce themselves.
Right, good afternoon ladies and gents. My name is Alex McMullen, CTO International at Pure. Been with the company now, just coming up on my 5th year, but came from the customer side. I started off in engineering and software, went through to this city, spent some time in investment banking, and joined Pure with the ambition of fixing the storage industry, but also transforming the data industry with it. Michael.
Very good. I'm Michael O'Connell, Chief Analytics Officer at TIBCO. I lead a lot of our innovation work streams, especially in the area of AI, machine learning, data science. I run a global team of data scientists, and we get involved in some of the product configurations, work closely with our customers. 1 foot in product, 1 foot in customer leads to a unique perspective on how to best configure our products to generate the maximum value for our customers. And I also heavily involved in our ecosystem, our community, partners, and so on, especially with Mercedes, a great partnership we have here.
Cool, thank you. So Matt, can you tell us how this partnership came about and how the various bits of it work?
Yeah, okay, so it probably goes back about 3.5, 4 years with regards to Pure, and about 18 months, 2 years with TIBCO. And we've spent a lot of time over the years trying to find ways to get IT out of the way of the business, to enable the business to do things better, smarter, faster, more accurately, whatever it might be. So starting with Pure, that started quite simply. We had a dire need to improve our storage infrastructure. We went out and we spent probably 9 months looking at a lot of vendors, probably 12 or 13 different vendors, got it down to 2 or 3, and very quickly worked out once we got to the last 2 or 3 that actually we didn't need to worry about performance. What we needed to look at was other things. So for us it was simplicity, and ease of use, ease of configuration. Then there were some other bits and pieces around actually the evergreen story, also they loved the storage guarantee that really made it a no-brainer for us to start working with Pure. And the more we looked into it, the more the commercials made sense, the more the performance simplicity made sense. I can tell some stories about that in a little while, but on the TIBCO side it probably started, well actually 4 or 5 years ago, we started looking at the TIBCO product, Spotfire in particular, to try and visualize data. But it never came to fruition for one reason or another, a number of times, and then late 2016, early 2017, we started to really look at how we could change the way we visualized our data. We had a lot of people within the business that were very clever people, and they were spending time creating code to visualize our data, rather than actually spending the time to analyze the data. So as Michael alluded to probably later on, if they're spending the time writing code, they're not actually using their brains to really improve the performance of the car. They've only just now been able to visualize what they should be trying to solve. So with TIBCO it gives us the ability to straight away have extra dimensions to the data. People now can turn around and actually really use their brains and be engaged. Helps retain staff as well, because they're not doing boring, mundane work now. They're really getting challenged at how to improve the car performance via data, and with Pure in the background, making sure that we can access that data, in real time as fast as possible. So between the two, it's a great partnership for access to the data and then visualizing it as fast as we possibly can.
Cool, thank you. So Michael, can you tell us a couple of specific use cases, bring it to life with the sorts of things that you've been doing?
Sure. So we work in R&D on the car, various components of the car R&D process, configuration of the car, and then strategy of the race. That's sort of 3 broad buckets. On the R&D side, Matt mentioned this morning, gear changes. So, Lewis is a bit of a gear change freak, about 3,000 changes per race. Each of those takes a couple milliseconds. And, in the lab, we get data slices throughout that couple of milliseconds, and we look at a number of variables to figure out anomalies, We want to make the changes that are occurring on throttle or without throttle. We want to understand those and make sure we configure the car in a way that is conducive to performance in that regard. It's an example of R&D. Yeah. All the way to the other end of the spectrum with strategy, we've been fitting a number of machine learning models to look at overtake phenomena. So looking at overtakes in terms of the tire type we have on our car versus the cars in front, the tire age, the latent speed differential, position on the track, all of those sorts of things to figure out, what are some of the factors that affect our ability to overtake another car. And that gets us more into the strategy team where we're, understanding and helping with the strategic considerations of the race. And then somewhere in the middle of that, the car setup and getting involved in some of the simulations, whether they're simulations based on differential equations from, phenomena or physics phenomena, or whether there's some more empirical simulations about, how to configure things for certain tracks and so on. So there's a gamut of really interesting problems, and we've got a lot of great engineers that we work with to address some of those problems.
Cool. And specifically, how important is machine learning and AI in terms of that data presentation and the things that you build?
Well, machine learning, I mentioned with the overtakes, we have a number of machine learning approaches to figuring out, based on historical data, what we might set up as scenarios for doing overtakes. So we look at data from races. We've looked at the last 2-3 years of data from all of the races. We've developed a custom data connector for bringing those data into Spotfire very quickly. So lets the teams in Brackley look at the data, also our own data scientists, and then figuring out what are the factors that are affecting overtakes. Each year we seem to get a slightly different collection of tire types with different softnesses and so on. So we've figured out how to calibrate the models in deltas between our car and the other cars, and so they can change the tires as much as they like, and we still have a model that calibrates itself against those different tire types, which is an important predictor for how you run the race, obviously.
So,
and I guess one to add on to that, so that is a supervised machine learning model where we've identified all of the overtakes for the last couple of years, and we've narrowed those down, and now we're training models to predict those. On the unsupervised side of the house, where we're just looking for anomalies in the gearbox and so on, we're looking for a space of variables and what are the outliers. When you've got multi-dimensions, how do you find outliers and anomalies in multi-dimensions? So that's an example of an unsupervised model. There's no real target variable in that case. You're just looking for outliers and anomalies. I say it's kind of complex because there's a lot of data, a lot of columns, and it's not just a two-dimensional scatter plot and spot the outlier. It's multi-dimensions. You're trying to search and weave your way through. So both supervised and unsupervised machine learning models are in play in the work that we do with Mercedes.
Cool. And how important is the timeliness of that analysis? So clearly, historically it's taken hours or days. I'm sure there's a drive towards more real-time insight.
Yeah.
Has that come about? How important is
that?
Yeah,
all of those three use cases, there's real-time considerations. When you're in the lab, you're doing R&D, you want that to be as efficient as possible. You want to, when you run a simulation job, you want to understand, is that going to be a good one or a bad one? You want to get onto the next one? Productivity and efficiency of the teams doing the engineering work make real-time a factor even when you're just doing R&D. I'm going to say just, but that's an important part of the process, Matt, right?
Yeah, so to put it into context maybe, so if you talk about the strategy simulation about the overtakes, if you think about the decision about whether to stop the car or not for a pit stop, if your strategy simulation says overtaking is impossible, then you don't want to come out behind a car. So then you're changing your decision, well, have we got the tyre life and the performance to get ahead of the car for a pit stop? If you know that you can actually easily overtake, maybe the decision is now different. So that real-time piece is actually really important. So there's various models that are always changing. So that's just one of the inputs, is how easy or how in the past have people overtaken and they've been successful. They might have overtaken but then got re-overtaken because it actually is really hard for the next corner or next straight, whatever it would be. So it's not as simple as can you overtake. Yeah. There's many other variables in there, so real time is important. The other data analysis we're talking about, we used to take days or weeks to do some of the different pre-event and post-event analysis. Now we're into hours or a day to do that. So we can now do multiple iterations in the week leading up to an event. Whereas in the past, maybe we could only do one iteration leading up to a race event. So real time would be lovely, but we need more and more and more compute to do that. At the moment, we also need brain power of humans to turn around and look at the data. So what Michael's alluding to there is that being able to look at anomalies means that actually people are no longer looking at as much data because they're now only looking at where the data is different. Is it different for the right or wrong reason?
So you're cycling the R&D as well as real time on the operations. It's both areas benefit from rapid iteration, as Matt pointed out.
And it's really important for us as well that you've got to think about access to that data, whether it's trackside or in the factory. We've got anywhere at the track, we're limited on the number of people that can travel. So there's a limited number of people looking at data, but we transport that data across the world almost in real time. Speed of light is the limitation in most cases. And then in the factory, we can have up to 300, 400, 500 people looking at the same data again. And this is where Pure really helps us, because if you think that you've got one data set, the contention on data, on the storage used to be, I couldn't mask it from users.
Yep.
With Pure, I don't care whether one person or 500 looks at it, it's the same performance now. So now you can have as many people as you like on a Friday of a race weekend trying to improve the performance of the car based on data that's hopefully now anomalies rather than the norm.
Cool. So Alex, can you tell us a little bit more about how that's achieved? It's no secret that the volumes of data are huge and ever increasing. So how have you stayed on top of that and through the more, I wouldn't say mundane, but the engineering required to do the sexy stuff on the right-hand side?
Okay, I'll try and cover that all quickly then, Richard. So Pure's been working with Mercedes for 3.5, 4 years now. We've enjoyed that partnership, obviously. It's been great for us and hopefully great for the team as well. The primary areas that we deal with, we are their data storage platform. We hold all the data from simulations, from the factory R&D, but also for the usual IT infrastructure kind of capabilities that every small, medium, large company has to have. But we also, in a fairly unique situation, we take our equipment to each and every racetrack. It goes in a flight case, on a bus, on a truck, or an aeroplane. It goes to the same place the car does. Engineers put it back together, turn it on, and hopefully it gives exactly the same results every time.
I hope.
We hope too, indeed. The biggest thing for me that was our initial takeaway, Matt mentioned this earlier, in terms of the performance side of things, the data rates from the cars are governed and limited by the FIA. We calculate we could probably support about 12,500 race cars going around the racetrack with the existing equipment. So we have some headroom to maneuver on that side of things, and that's good. A little bit more to go, that's fine. But the thing for us is to deliver the data as and when it's needed to, whether it's in Brackley or whether it's at the racetrack itself, as well as all the other things we'll talk about later in terms of simulations and the FEA and the CFD side of things too. But for us it's really about getting the information to as many people as need it, and hopefully, Pure, we're not confident enough to suggest that we've made the car faster, but we certainly believe we've empowered the engineers, the data scientists, to make the car faster at Mercedes.
Cool.
I guess there's one thing, just to add to what Alex just said then. Realistically, we're no different to any other IT department in any other business. The difference is we've got a very public end product that we iterate probably faster than any other product, even a software company probably. I don't know of a software company that's probably going to put a production version of a software tool out every 375 hours, worst case, that's 2 weeks. We probably do that every week, I mean. So for us, iteration is incredibly important, but we're just a normal IT department from any other point of view. We're a fairly small team of part of a 800 plus company, so small, medium enterprise, but we have to try and do everything in a much faster turnover, more iterations faster than most other companies. That's where the likes of these guys try to simplify things, speed it up, whatever that would be, to try and give a better result that you guys see on the telly every week or every other week.
And as with any other IT department, the issues are quality and getting it right and making sure that you're picking the right solution on the day.
Yep.
Given the speed of everything else that's going on, how do you maintain that discipline and not do something horrible?
So part of it's actually partnering with companies like TIBCO and Pure. Our other partners that we've got as well. It's trying to make sure that what we're doing, bleeding edge hurts. So we can't afford to be right at that point, but we can't be far off of it, because otherwise our competitors will be. And if we're jogging along at a standard pace, we'll only go backwards as far as F1's concerned. Yeah. You've always got to be probably faster than that jog, but are you able to keep up a sprint all the time is probably unachievable. So it's trying to pick the right technologies at the right time. I said earlier, the reason we picked Pure was the first thing was simplicity. We actually had ourselves over for probably 6 weeks because they came in and installed it in about 2 hours, and we left it for 6 weeks because we weren't sure what to do with it, because it must be more complicated than we were told. And then we actually tried it, and we put some production workloads on it, just having a bit of a play around their IT workloads. And we took things like an SCCM report that was a minute and a half down to about 5 seconds, and all we did was move the SQL database from one piece of storage to another, nothing else. And all of a sudden we were like, whoa, hang on a second, we're missing a trick here. So we just started putting production workloads onto this. There was no way it was leaving at that point. So the love my storage guarantee was brilliant from Pure's point of view, but from mine, the business instantly saw a performance improvement. So it sold itself on a performance improvement, plus the fact IT were now out the way. We'd removed a number of bottlenecks straight away. So everything for us is about trying to keep IT quiet, silent, out the way. But at the same time, I've got to give performance and think about how we're going to deliver performance enabling infrastructure to the business before they've told me what their requirement is.
Yeah.
So the headroom that Alex just said about the 12,000 cars, I'm sure in some way or another the business, if they knew that, they'll start chucking more requests at me that I'm going to have other bottlenecks to worry about rather than the storage.
Yeah. And given the importance of the analytics and the how easy it is to convince the business to actually use either the latest algorithm or the latest process. Many organisations struggle with it's brilliant, but proving that it's better than what went before or human judgment. Is that a wrestle for you guys, or actually do people go with it?
Two different parts to the question, I guess. So from a machine learning AI point of view, actually it's been a real struggle because there's a number of the senior management just see it as fancy data analytics. They don't see it as anything different. You've got to have that clever person, that data scientist, to turn around and create the algorithm. Otherwise, it's only just a person that's still doing the analytics. It's just they got a faster computer to do some calculation. We've got one or two pieces that are just beginning to come to fruition now, where I think we could probably start to say we really have got some machine learning. I can't talk about them, unfortunately, because they're in two use cases that are both very performant. So for obvious reasons, I'm not going to say anything here. But they're the first one or two where we really are starting to see the heads turn and opinions change. As far as quantifying or getting the business on board, the story I tell quite often is that a front wing roughly is £100,000, roughly a tenth of a second of performance. So I want to spend £100,000 on some IT, where's my tenth of a second? So that's a very difficult sell. Unfortunately, that means I end up being sometimes the negative IT person. Well, I can make it stop because I can make the car stop. But you end up you don't want to go into that conversation all the time with a negative connotation to afford a new piece of technology. So it's actually quite a difficult conversation. Sometimes, with Tibco, it speaks for itself. We don't have to turn around and do that sell. Just show them simply pointing at some data, actually how quickly, and the strategy piece is a good example where there wasn't a lot of time and effort went into that at early doors to get people to understand what could be done. It was then it's pointing the data scientists at it, teaching them. We had to teach them race cars and why they were seeing certain things in data, but once we taught them that, actually they were away and they were coming back with hundreds of different variations and thoughts because their minds work differently to probably what yours and mine do.
I think one turning point I noticed was when we built the custom connector to the SUS systems and some of the other systems, so the data could be very quickly brought into Spotfire and visualized. And pictures worth 1,000 words sometimes. Yep. And so a lot of people got converted by just seeing the data and visualizing some of the patterns.
And that 3D version was the telling point for a number of people. Everybody's used to seeing data in a 2D view. But then you want that third dimension, and as Michael says, there's quite often a fourth, fifth or sixth dimension to it.
Yeah.
But once you can see at least three, you could, actually, my decision making was faster, was quicker, was more accurate.
And how consciously have you thought about those users as different use cases? So I can imagine you've got, people making race decisions, data-driven, yes, but fundamentally about the race versus data scientists who, are much more in the data. They kind of have different needs.
Well, sure, everybody wants to visualize the data, though. That was kind of a ground level, ground zero kind of capability that I think kicked a lot of things off. And then some of the feature engineering. So I've mentioned that overtake model. So every X variable in that is also a model. So you're kind of building a model of models. And so you have to start to get under the hood of understanding what is the tire degradation model as a function of lab or time in usage and things like that. So visualizing the data and understanding the relationships visually, and then putting those things together into a prediction is a multi-step process. So I think we've made a lot of progress. I mean, every time I go to Brackley, some months apart, you see more people using the software, more people looking at the data, and now as we're starting to get more into the real-time use cases and being able to replay data from a race, find an area where there's something happened, highlight that, and then drill down into the underlying data and understand what's the reasons. it's not enough to just look at a report of what's happened in the past. You've got to understand not just the what, but the why. What's the root cause of that? Spot the fire in the data? Where's the action? And kind of drill into that and understand that visually and also from the modeling perspective. So you kind of go from data access to feature engineering, building the X variables, to visual analysis, and then start to get into predictive data science type things. It's kind of a journey that we're on, and different parts of the organization are at different stages of that journey. Some are all the way up to the speed with the latest machine learning stuff. Some people are still looking at the data. It's sort of a heterogeneous population, wouldn't you say, Matt?
Yeah, definitely. And I think one of the things that, again, relating back to Pure with TIBCO, is that one of the areas of the business, I said we're 800 plus staff, so not a huge business. We've got somewhere in the region of 250 key line of business applications, which for a business our size is crazy. But at the same time, we also generate 45 to 50 terabytes of data a week, which isn't normal for an 800 plus staff. So, and that data isn't generated in across the whole 800 people. Probably about 15 to 20 people generate that 50 terabytes. And that 50 terabytes for us, we were having forever looking at different parallelized storage systems, complexity IT just doesn't want to have to manage, to turn around and be able to take that amount of data weekly. I won't even get into bothering to talk about how we back it up and how we are.
Well, we've had a few questions from online about actually how do you architect the data so that it's available wherever you want it in the world, replicated in real time everywhere in the world. It sounds a slightly impossible challenge. So how do you pull that off?
We're clever and we're very selective with the data that we transfer around the world. The 45 terabytes I don't even entertain. That's in the factory. And a lot of people talk about the edge to cloud and everything else these days, and we're very much having to put the compute where the data is. So wherever we are in the world, we're trying to make sure that we've got the right compute in the right area of the world. So whether it's trackside or in the factory. The big thing about the 45 terabytes, just quickly, is that is generated very, very quickly by a large high-performance compute system. What Pure's allowed us to do is not only generate the data, but now to look at that data and start to point things like TIBCO and other software technologies, some in-house, some open source coded, for us to turn around and actually start to data mine some of that, I would say historic, but it's fairly realistic, fairly real-time data, which in the past we were struggling to write it, let alone now try and get systems to keep continuously mine that data. So we have FlashBlade and FlashArray from Pure, and we have that so that we can have real high-end performance, but at the same time I've still got almost the same level of performance in what's classed as probably a tier 1 infrastructure, but it allows us to use that as a large data lake that we can start to mine and look for differences. We'll spend too long if I start talking about how hard that is for us, because the definition of the data is just too hard. But moving data around the world, we're very selective is the answer. Yeah. We bring real-time data telemetry from the car back to the factory, and realistically that's just speed of light is the time, and then we'll bring back the required data from the track to the factory to be able to recompute the same information that we had at the track. So we don't bring the computed version back. We'll bring the raw data and recompute it in the factory. So we have two copies that we know binary-wise are the same, because they've had the same calculations performed on the same data. Then in the factory, we've just got multiple iterations or more compute to then turn around and do more analysis of that data.
I would add something on the top of that, in that if you look at the Mercedes team, they're very unusual in a number of ways, as Matt's highlighted, but they leverage technologies from investment banking like Monte Carlo simulations. They leverage technologies like airflow modeling from aerospace and space customers. That's one of the things that Pure can do, is bring that experience, life lessons, if you will, to bring all those different technologies together and aggregate them in a very specialized, I'd argue almost niche part of that high-tech industry. So we can bring that kind of net aggregate capability to how to run 8 or 9 different parts of a data business and bring them together in a somewhat organized fashion in the middle.
And I assume those capabilities are often delivered by different vendors or doing, other partners doing processing or analytics for you in addition to the TIBCO. How easy is it to, facilitate them with the data, but also then obviously have controls and security and to keep the governance on track around all of that?
Yes, it's an ever-increasing challenge. As Matt said, we ship data either over the internet or over satellite links back to Brackley, and all that data gets encrypted, of course, but that's very precious and very tightly held data for a whole bunch of different reasons. The Formula One industry is very good at protecting data from other teams as well as their own, and as they should be. but it's equally becoming a much more valuable commodity outside of there. If you think about the focus on autonomous driving, everybody now is working on the best way to drive a car by computer, and there are some very close parallels to the technologies that Mercedes are working on. And to be fair on that side also, on the TIBCO side too. So we're all trying to make the team better, not just because we're all fans, but because it's a fascinating use case for state-of-the-art engineering with data.
It's interesting that the fans comment, because these guys do become an extension of the team.
No.
And a virtual extension, because they get actually pulled in and drawn in by the allure of actually the technology, but also the fact that you can see what you're doing week after week, and you can see the improvement that you're helping within the team. So these guys actually, Pure, for instance, they tell me about issues with my IT infrastructure before I know about it from IT. So every now and again, Alex has actually texted me, Matt, we've had a power issue at work, and so he's telling me before it's actually come through. It's a bit strange, a bit weird, but again with the TIBCO,
in a good way, obviously.
With the TIBCO team as well, there's a number of the data scientists have been on site for different periods of time, and sometimes that's been because they've wanted to learn and they've wanted to understand more, and actually they've been taking that off to use elsewhere, but actually we've just iterated way faster than what other people would do, because once we actually get the hang of things, our 0 to 100 is, we do accelerate very quickly. We might be a bit slower getting off the mark sometimes, but once we understand the technology is good for us and why, man, does it move fast.
And just to piggyback on a couple of comments there from Alex and Matt, we didn't learn how to do anomaly detection at Mercedes in the last 18 months. We've been doing that for like 20 years, right? So it's like, and Alex's comment about Monte Carlo simulations, we do most of the risk management simulations for the financial sector, and real-time trading surveillance, all that kind of stuff. We've been doing, anomaly detection for many years in many industries. So we bring that to the table, that experience from multiple industries, and then as we get to know the subject matter, as Matt said, and as the analysts start to understand the tools and how that works, those techniques for anomaly detection, finding outliers in historical data, applying that to real-time feeds, or looking at the interaction between what's happening now and what's happened in the past. Anomaly detection, finding the outlier, finding the anomaly, and then understanding the root cause of that. That general set of techniques applies in many industries, and so being able to sort of instantiate that at Mercedes has been a lot of fun. And we bring some other industry perspectives, and you bring all of the context you have around the aerodynamic properties of the car. This is an amazing feat of engineering. Combining that with some of the general techniques we have for anomaly detection, risk management, those sort of things is really, I think both Alex and myself have really enjoyed applying our knowledge from other industries into the Mercedes team and vice versa.
And how have you facilitated that at a practical level? Do you have jointly badged teams with your data scientists learning more about what motor racing is, and clearly educating motor racing
back and forth. I noticed Matt, saw a couple of my data scientists were coming up and saying hi to Matt there today after his talk and that sort of thing, right? And so people back and forth to Brackley.
I went to the US probably 12 months or so ago, met some interns that Michael was actually there. It was one of their first days in the company, and we were just sat talking about our data and the structure, and they were asking questions because they'd never seen a Formula One race. So some questions for me, I was like, why don't you understand that? But once you started to understand, all you got was more questions. It's a bit like having your kid ask you, but why? But then once they understood, actually they were coming back with things that I wouldn't have thought about. Because I just would assume, because I've been in the sport for so long.
It's just the way it is.
And they would ask questions that you'd go, I hadn't thought about that.
This cross-fertilization that you get from just the life of a data scientist in multiple industries can be really quite insightful. And sometimes it's good not to know anything, and you ask a dumb question that turns out to be an interesting one, right?
Well, that's the same with the Pure team. We turn around and we'll start to use the storage in a different way for a new software application, and every now and again they'll go, what are you guys doing? And then we explain, they go, we've not seen that use case before, so why are you doing it that way? Why aren't you doing it this way? The other companies that we work with, they've done it this way, and we go, we hadn't thought of that actually. So again, iteration of their learning, we're learning basically from the data and analytics they've got on how we're using the systems. So they're doing their own, I don't want to call it machine learning in the background, but basically data analytics of the system usage.
Yep.
They're learning it and then helping us to maybe advance quicker than we would have done on some of our standard setup.
Cool. And just while we're on the machine learning bit, again, one of the questions from the floor has been, so what specific tooling do you use for that? Is it how automated is the machine learning, or is it people crafting code as it's kind of traditionally been done?
Yeah, everything. We have point-and-click tools for doing machine learning that folks use. We have folks in Mercedes who have some R skills, so Stuart, we have some folks with Python skills. Our products, we design them to have, competitive in-class drag and drop, point and click pieces, but there's also extension points mainly for Python, for R, for big data systems. So, folks at Mercedes are extending the products to write their own data functions to solve their own problems, whether it's differential equation based and mechanics based, or whether it's empirical based on data that we're getting from Pure or from the SUDS data we get across the different races and the different tracks. So it's a mixed bag, really.
Cool. And so last couple of questions I probably should ask all of you there. The first is, so the application of, as you say, a business that's running at 1 million miles an hour faster than most, faster than perhaps any other, where do you see this spilling out back into sort of more conventional real-world applications? The things you developed this season, how quickly will they appear in the real world or in the normal world for us mortals?
So I guess autonomous vehicles would be the great one for me to try and... So Daimler are obviously spending a huge amount of time and effort now to look at how they're going to do autonomous vehicles. We've spoke about this a couple of times today, and where we're already using techniques maybe that are looking at the moment at tyre temperatures, for instance. Maybe those sensors in the future might be picking up heat sources of people or animals or something else in the future. So different sensors that we're looking at maybe for our particular requirement of the car. In the future, how are they going to help Daimler to have a safer car, however that would be used on the real roads, if you like. There's lots of things where we're learning from Daimler about new technologies, new sensors, new techniques that we look at. We iterate way quicker than what Daimler will or can. Then actually we've just leapfrogged a little bit for Daimler. So we've learned because they've given us a great new way of looking at something. We'll iterate quick, hand it back, and then Daimler have now just taken a leapfrog in a certain technology. We were saying earlier, there's so many different ways that you can think about autonomous cars. If you go back a few years, people think about ABS brakes, your flappy paddle gearbox. All those things came from F1 over time. I think autonomous car will be much quicker. But I think the other thing is the iterative change that we have. I'm not saying Daimler's going to bring out a new car every week, but they need to and will need to, and that they will, bring down their, however many months it is at the moment for a new iteration of car, that will come down and down and down, particularly with software updates in the cars. Those will get into much shorter lead times.
Yeah. It's like the F1 race is a compressed version into a couple of hours of what the general driver experiences in a couple of weeks, probably. So it's like, and pushing the boundaries. I mean, the speed at which Lewis goes into a curve, the regular driver doesn't do that. So pushing the parameters of operation of a car and how that might apply then. Those learnings apply to a longer time span of a regular car usage. That's kind of some interesting stuff that Daimler's looking at.
Yeah. And Alex, there's obviously applications of the things that are being developed, but there's also where you're learning to handle the data and the engineering behind it. Are there other industries that, quite frankly, could learn from the ground you guys are breaking?
Yes, there are. I would finish on the car side by saying I'd like cars to be smarter so that they recognize my son is driving my car, not me, and then keep them at 40 miles an hour. Sorry, son. But the bigger ask for me, I think, is healthcare is a fascinating industry because we are so far behind in terms of what we really understand about everything from the human brain through to oncology. So computer classification of images, computer vision techniques for CAT scans, for X-rays, tumor analysis, but also for genetic disease. Those are what we think is the most exciting potential, and it's a huge parallel with large amounts of data, lots of compute, lots of analytical software to get ultimately a better outcome for all of us. It's a continuing source of disappointment for us as an industry that we can't fix some of the more widely held medical challenges we have today, and it's an area that we are strongly focused on.
Cool. And there are some elements in there I can't talk about again for performance reasons, but where we're doing some of that computer vision work, which will be taking weeks and weeks out of man hours of time to do things, for us to turn around and allow those people to go and do a less mundane, boring job, looking at images. But if we can turn around and get those people excited, they're more useful to the business doing a different job. They're bought into what we're doing, so we get more performance, you get more out of the user. So there's a lot around the cultural side that can benefit from actually the machines doing the leg work and the grunt work around that boring, mundane day-to-day, so people can get to do exciting things.
Cool.
Yeah, it's funny the way anomaly detection, we talk about doing that, applying that to the F1 car. Alex is talking about healthcare, it's almost like, when you've got a patient in a hospital, you're doing predictive maintenance on a human as opposed to a car. But some of the techniques are similar. You're looking for patterns that you're getting, blood pressures and so on. You're looking at those trending just the same way as you look at pressures and sensor readings from the car. I mean, I know it's not exactly the same thing, but some of the mathematical techniques and some of the empirical data analysis techniques are quite similar. You look at historical data, you find a pattern, you apply that to a new real-time data stream, you identify the anomaly, you get into the root cause, and you understand what you're going to do to address it. That's a general sort of design sequence from data ingestion, feature engineering, visual analysis, model development, putting that into production and managing the model through the life cycle. That is in common, and that's where some of the cross-fertilization we get from healthcare to engineering and cars sort of takes on a really interesting life.
Definitely.
Cool. And so probably the last question, I'm sure Formula One is true in terms of really well done this year. It was a fantastic year. We've forgotten about that. What's coming next year? So what are the things you're really looking forward to? Obviously, there's things you won't be able to share, but from sort of advances you're hoping to bring on, or things that really get you excited as you kind of look forward to the next season.
Matt, have 5 minutes to enjoy the success of last week.
Yeah, actually, you say about that. So yesterday, obviously, some of the team were back in the factory, but today's actually when everybody's back. So we're down here talking to you guys today, but back in the factory is where basically all the drivers are back today, all the senior management. So they're having some various different celebrations in the factory today, because actually it is a big achievement. Still doesn't really hit home for me a little bit. Sometimes I get that bar humbug, I get told in the office. I don't celebrate the success very well. But 5-time double world champions, it's only been done once before. So we should be proud of it, and I am, but it's just I'm not outwardly over the moon, from that point of view. But for me, I've still got a job to do. We've still got another race to go. I'll probably celebrate after that. I'll chill out a little bit. And then the winter's actually our busiest time from an IT point of view. So we've got a lot of change planned for the new year. A lot of things to turn around and help with more compute trackside, how we're going to move data around, what we're going to do in the factory with some different analytics tools. But at the same time, we've got a new ECU on the car which will generate probably 4 times the amount of data per lap. Per outing of the car, because we can generate, unfortunately, the same amount on one lap or a whole race. But so I've got more storage demands for next year. That's more data to look at with no extra people. So we've got to try and find ways to be cleverer. More data doesn't mean you can make a better decision if you don't look at the right data. So we've got some challenges for next season, which they're all good. They're what that's why I've been in the sport been in the same team for 20 years, let alone the same sport. But so it's what keeps us motivated, keeps us excited, really.
Cool, good. You guys?
Yeah, for me, it's, as Matt said, there's huge regulation changes next year around the shape of the car, how effectively it can race. So what that means is it's more of what Mercedes is good at in terms of evolving the design, using our technology, Michael's technology, to make the car better more quickly. And we look forward to hopefully being a small part of that success story, number 6.
Yeah, be nice.
Yeah, better, faster, cheaper. It's more of the same, and we want to do more next year with more data, and keep going. Improve the simulations, improve the what-if scenarios, improve the throughput, improve the cycle time. Better, faster. That's kind of the mantra.
Cool. Well, look, I think we'll bring it to an end there. Thank you, guys. A really interesting panel discussion, and Formula One is clearly the antithesis of working really hard, developing things really quick, where the benefits are visible. So, good luck with the next season. Well done for this season, and hopefully see you again.
Thank you, Richard. Thank you all. Good afternoon.